We have this intriguing correlation between the amount of oxygen, O2, that's disappearing from the atmosphere and the amount of oxygen that's showing up in the new CO2 in the atmosphere. But correlation is not causation. We need stronger evidence. We need a fingerprint that tells us where the carbon dioxide is coming from. And to do that, we have to take an excursion into atoms and their isotopes. The universe is composed of 92 different kinds of naturally occurring elements, each of which has a different composition. Each atom has three constituents: a proton and a neutron bound together in the nucleus, and an electron orbiting around outside. Each atom is defined by the number of protons and the equal number of electrons that it has. So hydrogen has 1 proton, helium has 2 protons, carbon has 6 protons, and oxygen has 8 protons. While the number of protons and electrons is fixed, the number of neutrons can vary. And so we have different kinds of carbon atoms, designated carbon-12, carbon-13, and carbon-14, representing carbon atoms with 6 protons. They have to be 6 protons if they're carbon atoms, and 6 neutrons, 6 plus 6 is 12, 6 protons and 7 neutrons, that's carbon-13, and 6 protons plus 8 neutrons, that's carbon-14. These appear in very different ratios. Carbon-12 is much more common, making up about 98.9% of the carbon atoms we find in the world. The carbon-13 is about 1%, and the carbon-14 is extremely rare, about 1 part in a trillion. You might think there's only 1 part in a trillion. That's so incredibly rare. That's like the Empire State Building filled up with M&Ms with 1 green M&M and all the yellow M&Ms. But in fact, atoms, you have to remember, are very, very small. And in fact, in a single fingernail clipping, there are 10 billion carbon-14 atoms to go along with the trillions of carbon-12 and carbon-13 atoms. So they provide an important signature.